You float at the surface. The water is warm, the sun is high, the horizon stretches in every direction. You take a breath, hold it, and slip beneath the waves. Just below you, the seafloor falls away. Not a few meters, not a few hundred, 11,000. The deepest point on Earth waits beneath your feet, and somewhere in your imagination, a thought begins to form. Could you swim there? Could a human body survive it? The answer is one of the strangest in modern biology, and almost no one knows how strange it actually is. The Mariana Trench sits in the western Pacific Ocean, a curved scar in the seafloor about 2,550 kilometers long and 69 kilometers wide. At its deepest point, called the Challenger Deep, the floor lies 10,935 meters below the surface. That is deeper than Mount Everest is tall, with 2 kilometers left over. If you drop the entire Empire State Building into it, it would vanish. If you stacked 25 of them, the top one would still be underwater. Most people imagine the trench as a colder, darker version of the ocean. It is not. It is something far stranger, a place where physics, biology, and time itself seem to behave differently. And to understand whether you could survive there, you have to understand what would actually happen to your body on the way down. It begins with pressure. The air around you right now is pressing on every square inch of your skin with a force of about 14.7 pounds. That is 1 atmosphere, the weight of the entire column of air above you reaching to space. You do not feel it because your body is built for it. Your cells push outward with exactly the same force, and the two cancel out. You are, in a sense, perfectly tuned to the surface of this planet. Now imagine descending into water. Water is roughly 800 times denser than air. For every 10 meters you go down, the pressure on your body increases by another atmosphere. At 30 meters, you have 3 atmospheres squeezing every inch of your body. At 100 meters, 11. By 300 meters, the air in your lungs has been compressed to a fraction of its original volume, and most untrained humans are unconscious. The current record for unaided freediving belongs to Herbert Nitsch of Austria, who reached 253 meters in 2012. He suffered brain damage on the way back up. That is what the ocean does after just a quarter of a kilometer. Now keep going. To the bottom of the Mariana Trench. At 11,000 meters, the pressure on your body would be roughly 1,100 atmospheres. That is more than 16,000 pounds per square inch. More than 8 tons pressing on every square inch of your skin. Your bones would not break. They would dissolve. Your tissues would compress so violently that the air in your sinuses, your ears, your gut would not have time to escape before the cavities collapsed. Your lungs, which contain roughly 6 liters of air at the surface, would shrink to less than 1 teaspoon. Most of you would be paced before you got close to the bottom. That should have been the end of the story. For most of history, scientists believed nothing could exist there. The pressure was simply too much. The light was gone. The temperature hovered just above freezing. Whatever life was, surely it could not be down there. Then came the descents. In 1960, 2 men named Jacques Piccard and Don Walsh climbed into a submersible called the Trieste. It was a strange-looking vehicle, a thick steel sphere hanging beneath an enormous float chamber filled with gasoline, designed by Piccard's father, Auguste. They sank for nearly 5 hours. When they finally touched the bottom of the Challenger Deep, Piccard looked through the porthole and saw something impossible. A flatfish, a living, breathing flatfish moving slowly across the mud. Marine biologists at the time refused to believe him. Pressure that great should have crushed any vertebrate. But the trench was alive. That single sighting changed everything science thought about life on Earth. In 2012, the filmmaker James Cameron became the first person to reach the Challenger Deep alone. His submersible, the Deep Sea Challenger, was a vertical capsule barely large enough for one body. He spent nearly 3 hours at the bottom. He saw small, translucent creatures, sediment shimmering with bacteria, and an absence of fear that he later described as overwhelming. His sub was designed to withstand more than 16,000 pounds per square inch, and even then, hairline cracks formed in its windows. In 2019, the explorer Victor Vescovo descended in a vehicle called the Limiting Factor. He spent 4 hours on the seafloor of the Challenger Deep, longer than anyone in history. He saw plastic. A human body, unprotected, would not get within a kilometer of where these men have gone. But what if you were inside a suit, a perfect theoretical suit that could withstand the pressure? Could you walk down there? This is where the science becomes harder to explain. The deepest atmospheric diving suits ever built can operate at around 600 meters. That is roughly 5% of the way to the trench floor. Beyond that, the joints of the suit cannot move. The pressure differential is too extreme. Engineers who have built the most advanced diving suits in the world have stated openly that a human-rated suit capable of reaching the bottom of the Mariana Trench is currently impossible with known materials. Steel deforms, titanium fatigues. Even the most exotic alloys cannot retain shape under those conditions for long. But assume for a moment that you had one. The pressure would no longer kill you. What would? The cold first. The water at the bottom of the trench hovers between 1 and 4 degrees Celsius, just above freezing. Without active heating inside your suit, hypothermia would take you in less than an hour. Your body would lose heat 25 times faster in water than in air at the same temperature. Your fingers would stop responding. Your heart would slow. Your blood pressure would drop. You would feel warm, strangely, near the end. That is your nervous system shutting down. Then there is the darkness. At 1,000 meters, no sunlight remains. By 4,000 meters, the world is so black that your eyes, even fully dilated, would see nothing. Some deep-sea creatures generate their own light through a process called bioluminescence, a chemical reaction in their cells. But that light is faint, sparse, and far apart. You would be standing in a place where the absence of light is so total that scientists who study it call it the perpetual night. And then there is something stranger, something almost no one talks about. Time perception breaks down in the deep ocean. Researchers who have spent extended periods in deep submersibles report a phenomenon called sensory drift, where minutes feel like hours, and the brain begins to produce its own visual stimuli to fill the void. Cameron mentioned it. Vescovo mentioned it. So did the divers in the Trieste. Your brain evolved over hundreds of thousands of years to interpret light, sound, and pressure, has no inputs to interpret down there. So it starts to invent them. You would not just be physically alone at the bottom of the Mariana Trench. You would be psychologically alone in a way no human has ever truly been before. There is no surface, no reference, no echo. Just water and silence and the slow ticking of your own heart in your ears. And yet, the trench is full of life. The deepest fish ever recorded is the Mariana snailfish, scientifically named Pseudoleperis suirae. It was filmed by researchers led by Alan Jameson of the University of Western Australia in 2017, swimming at over 8,000 meters. It looks like a pale, translucent tadpole. It has no scales, its bones are nearly transparent, its tissues are saturated with a molecule called trimethylamine N-oxide, or TMAO, which prevents its proteins from being crushed by the pressure. The snailfish does not fight the deep. It has been rebuilt by evolution to belong there. A human body has none of those adaptations. You have rigid bones, rigid air spaces, a brain that needs constant oxygen at constant pressure. You are a creature of the surface, optimized for a single thin layer of the planet that we mistakenly assume is the only one that matters. So the answer to the question is no. A human being could not survive in the Mariana Trench, not unprotected, not even with the best suit ever built. The trench is not a darker, colder version of where you swim in summer. It is a different world, governed by different rules. But here is the deeper truth. The trench is closer to you than the moon. It is part of the same planet you wake up on every morning. It shapes the currents that warm your coastlines, the storms that move across your continent, the oxygen that fills your lungs through the plankton at the surface. When Vescovo reached the bottom in 2019, he found a plastic bag. Even at the deepest point on Earth, you were already there. You cannot survive in the Mariana Trench, but the trench, in some quiet way, is already surviving in you. The salt in your blood, the rhythm of your heart, the trace minerals in your bones were all forged in the same ancient ocean that carved that scar in the seafloor. You came from there. You just cannot go back. Most of the planet you live on is unmapped, unexplored, and impossibly hostile to your kind of life. And yet, you carry the memory of it in every cell. So the next time you stand at the edge of the sea and look out at the horizon, remember what is below it. Remember that the most extreme place on Earth is not on another planet. It is right here, at your feet, breathing slowly in the dark. Thank you for watching. If you enjoyed this content, please subscribe for more videos. See you in the next one.